Algebra 2, set 22, uniform motion problems, equal distances, and similar triangles and proportions. Okay, so we'll be using the formula for distance, which is distance equals rate times time, to be solving problems. And in these problems that we are solving, the distances are equal. So you'll either have a problem where two people or things are moving in the same direction and they both travel the same same amount of distance, or they're going in opposite directions but they still cover the exact same distance. So we have distance equals rate times time, but then we have two of them because we've got two different things. So distance equals rate times time twice. So the way that we tell the difference between them is we use subscripts. So 1 and 2, or however you want to denote one and the other. So since distance 1 is equal to distance 2 in all of these problems, we can also assume that rate 1 time 1 is equal to rate sub 2 time sub 2. So the rates and times, the products of the rate and time, are equal to each other. So we'll start with an example. Roger made the trip on Sunday and Judy made the same trip on Monday. Roger traveled at 12 miles per hour, Judy traveled at 20 miles per hour, so her time was 2 hours less than Roger's time. How far did they travel? So the first thing that we can note is that they both traveled the same distance and they're traveling in the same direction. So the distance of Roger and the distance of Judy are the same, so that means that their rates, the product of the rate and times, are also equal to each other. And then we take the information that is given in the problem. The rate of Roger is 12, the rate of Judy is 20, and then it also says that the time of Judy is 2 hours less than the time of Roger. So we can put that into an equation. So now we just plug in. R sub r is 12, so we have 12 t sub r is equal to 20 t sub r minus 2, because we're substituting t sub r minus 2 in for t sub j. Now we'll distribute the 20, so 12 t sub r equals 20 t sub r minus 40. Subtract 20 t sub r from both sides, so we get negative 8 t sub r is equal to negative 40. Divide by negative 8 and t sub r equals 5. Now the question didn't ask how long it took, the question asked how far did they travel. So first we can figure out Judy's time. Judy's time was 5 minus 2, or t sub r minus 2. So Judy took 3 hours. But what we really need is to plug that in for the distance, which is the rate times the time. So the rate of Roger and the time of Roger is 12 times 5, which is 60. We can just double check. The rate of Judy and the time of Judy is 20 times 3, which is also 60. So we know that they traveled 60 miles. Okay, Brer Rabbit hopped off towards the briar patch at 10 kilometers per hour at 10 a.m. At noon, Brer Wolf began the chase from the same starting point. If he caught Brer Rabbit at 2 p.m., how fast did he run? So this is another case where they're starting at the same point and ending at the same point. They went the same distance. So the rate and time is equal to the rate and time. So the rate of the rabbit was 10 kilometers per hour, and we know that Rabbit took 4 hours. The reason why we know that is because he started at 10 a.m. and finished at 2 p.m., so that was 4 hours. And the time of the wolf is 2 because he started at noon and ended at 2. So we plug this in. We know r sub r is 10 and t sub r is 4. R sub w is what we'll be solving for, and we know t sub w is 2. So we have 40 equals 2 r sub w, divide by 2. We get the rate of the wolf is 20 kilometers per hour. Now we'll switch gears a little bit and we'll talk about proportion. So we can solve for the missing sides of these triangles by setting up proportions. So we can see that the triangles are similar because of the indicated sides. Or the indicated angles. We have angle, and we assume that the third angle is also equal. So we have similar triangles by angle, angle, angle. And when we can compare sides. So x goes to 5 as y goes to 8 and 9 goes to 7. It's very important that the order in which you set them up. So if I say x over 5, then I have to say y over 8. I cannot say 8 over y, or that would mess it up. So since I'm starting on the right and going to the left, I have to do right to left, right to left, right to left. I could have done 5 to x, 8 to y, 7 to 9. As long as I keep them consistent, it will work either way. But it has to be the same for all three proportions that you're solving for. So we're going to take two of them. We'll start solving for x is to 5, and we're going to use what's given to us, which is 9 over 7. So we only have one unknown. We'll cross multiply, so we get 7x equals 45, and therefore x is equal to 45 over 7. Then we'll take y over 8 and set that equal to 9 over 7. Cross multiply to get 7y equals 72, so y equals 72 over 7. Now we have been solving these problems using scale factor, and you can still solve these problems using scale factor. Just a reminder, the scale factor from the little triangle to the big triangle, 7 times the scale factor equals 9. So we're figuring that you would multiply everything by 9/7 in order to go from the small triangle to the big triangle. So the scale factor is 9/7. So 5 times 9/7 gives us 45/7, and 8 times 9/7 gives us 72/7, which matches what we got originally.